Alright, so this will be the topic that we are going to discuss today. Pasal dia ada kaitan. So, kalau kamu dah lupa yang tu, jangan payah banyak sangat makan ketupat kau ni. Sekejap. Siapa baru masuk? Masuk je lah besok ke, lusa ke. Okay, this is linear kinematics. I think that we have learned about it in in week 3 or week 4, something like that. Okay, kita dah belajar benda ni awal ni, linear kinematic. Week berapa kita belajar? Linear kinematics week 3. Okay, the end of linear kinematic is projectile. Yang kita ada 3 equation of constant acceleration. Do you still remember that? Last kali kita ada benda ni, V2 equals to V1 plus AT. Apa lagi kita ada D equals to V1T plus half AT square. Lepas tu kita ada V2 square equals to V1 square plus 2AD. Ni, last kali topik tu we have learned about this. Equation of constant acceleration. Do you still remember this?
Ingat sir.
Ingat ni refresher. Okay. So under linear kinematics, ni projectile. This is projectile. Okay, underneath linear kinematics, we have learned about 3 things. The first one is about displacement. Okay, kawan baik dia distance, where these two things is measuring up a linear case and the unit is in meter. Ni benda yang kita bincang dulu ni. Kalau dia lari 100 meter, distance is 100. Displacement, the shortest way. If they continue running, the distance is 200. Displacement, shortest street. If they continue running, the distance is 300. Displacement, 100. Okay, straight line. And if they continue, it will be 400. The displacement is 0. And all those being measured in meters since this one is linear. Ni benda pertama. Benda kedua, we have discussed about velocity. The rate of change in terms of displacement. So velocity being write as V equals to displacement over time. Ni benda yang kedua kita dah belajar. And the third one, we have learned about acceleration, or the rate of velocity change, where it can be written as A equals to V2 minus V1 over T2 minus T1. Ni sekejap ni. V unit dia dalam meter per second. And for acceleration, the unit is in meter per second square. Ataupun meter, mana bagi dia cantik sikit. Ataupun kita boleh tulis dia sebagai meter per second square. Ni. Ini benda yang kita dah belajar dekat dalam linear kinematics. So for now, for today, what we are going to discuss is actually angular kinematics. So angular kinematics is actually the same thing. They have displacement, they have velocity, they have acceleration, and the last part is actually relationship between linear and angular acceleration. So I hope that you still remember these 3 basic things. Okay, apa displacement, apa itu velocity, and apa itu acceleration. Alright. So this will serve as the notes for today's topic. Okay, ni nota ni. I need you to later on read about it. I'm going to show you in other versions. Okay, so ni nanti kamu bacalah. Dia recap balik what is kinematics, what is the definition of kinematics, pattern, character. Okay, and then what is scalar unit, what is vector unit. Okay, when we talk about kinematic, we are going to discuss more on vector. Okay, more on vector unit. Okay, apa itu vector unit? When you see vector unit, just remember this thing. Remember Cartesian coordinate. If you forget about Cartesian coordinate, some of your equation is not going to be right. Okay, because in Cartesian coordinate, it show you symbols. So anything that move downwards is negative, such as gravity. Gravity is moving downwards. So gravity figures dia negatif. Pasal tu kita kena ingat dia punya figures. Anything that move upwards is positive. Anything that move to the left is negative. Anything that move to the right is positive. When you see vector, you need to remember that unit have direction. Okay? That unit have magnitude. Apa itu magnitude? How much? Apa itu direction? Plus minus. Okay? Plus 10. Negative 10. The magnitude is similar but the direction is different. So kalau kita buat equation, katalah x equals to plus 10 dengan x equals to plus 10 minus 10, this will give you quite a total difference in terms of answer. And that is the reason why when we see a vector unit, don't forget to put on the sign. Walaupun dalam equation asal dia tak sebut tentang sign. Okay, ini peringatan. Okay, sekejap, siapa baru masuk tu. Okay, so after vector and scala, we have, this is what we have, what I said earlier, okay, about linear and angular. So later I'm going to show you both again. Okay, ni contoh. Okay, and this is the notes. So please take a look at this note later. I'm not going to discuss the notes one by one. Okay, so in angular case, the first thing that you need to know is the unit. Okay, the unit. In linear, I'm going to show you both linear and angular. In linear, the major unit is actually meter. Okay, but in angular, your unit is actually degree. Kita boleh tulis dia sebagai degree. And radian. Okay. So linear being measured like this. Kita ada satu distance and we measure from point A to point B. Either it is in a straight line, or it may be a curve, or it may be a pattern. Okay, so we are going to measure from the starting point to the end point accordingly to the shape. This is linear and it being described in meter. Okay, when we see angular, we know that it is degree, and then angular motion is a motion of rotation. Okay, in the shape of rotation. Maksudnya dia punya bentuk angular motion ni macam ni, dia tak ada bentuk lain dah. It can be a small circle, it can be quite a large one. But it will be something like this. For example, we take one common movement of human. Elbow flexion. Okay, kita ambil contoh mudah. We take elbow flexion. Okay, apa persamaan antara dua ni? First, when we talk about angular motion, it need to have this one. The axis of rotation. Same goes as the movement of your hand region. So the elbow will serve as the axis of rotation. Jadi bila kita nampak je benda macam ni, we know that this movement is an angular movement because siku kita ni, dia tak boleh bergerak ke depan macam ni. Pegang dia tu kan, tangan tu memanjang ke depan. It cannot be like that. If it goes like that, then it is a linear case. Okay, so human movement, especially at the joints, is angular movement. Okay, it's a rotation. So when we talk about rotation, like our hand, it can go this way in terms of flexion, and it can go that way in terms of extension. Ni pergerakan dekat angle. Siapa yang baru masuk? Tak ada pun. Pergerakan dekat kita punya siku. And this is an angular motion. Okay, pasal dia hanya bergerak in terms of angle. Dia ada angle, dia ada paksi. Alright. So why the unit of angular motion being measured in terms of degree? It's because of this. Okay. So the unit, kita ambil yang pertama distance. The distance in linear is this one, but the distance in angular is how much rotation occurs. Okay, let's try a bit or two. Okay, if a point move from A to B, ni pukul 12 ke pukul 3, what is the distance covered? How much distance covered by, katalah kita ada satu ni, jarum jam ni. How much distance covered by jarum jam ini when it move from 12 to 3 o'clock? Berapa jarak dia kat sini? Jarak been described in term of degree. So, berapa? 90
90 sir.
degree. If that clock hand continue moving up until 6, now what is the new distance? Tambahlah 90 lagi. Dia jadi 180 degree. So that is the distance covered. If the clock hand continue moving up until 9, you need to add up another 90, becoming 270 degree. And if it goes along the way, and then it already travel 360 degree. So the distance for angular being described in term of degree. Katalah jarum ni bergerak 2 kali. 1 kali, 2 kali. How much distance being covered now? Berapa sekarang? 2 kali 360. It become 720 degree. This is what we call angular distance. Okay, jarak dia. And in angular distance, okay, in angular distance being described as this one. Bulat, tegak. Okay, nama dia pi. Okay, kalau dalam linear, distance is distance lah, distance. In term of meter. Dalam angular, distance is known as pi in term of degree. Basic, okay, this is basic. Itu yang pertama. That is distance. Okay. Let's enhance our knowledge. Katalah kita nak buat squat. Okay, we try to do a squat. Okay. Let's say this is the starting position. The angle at the knee is 90 degree. Okay. Dia pun bergerak sampai dia boleh bangun atas sikit, which resulting kaki dia jadi macam ni, and the new angle is 170 degree. Okay. To do one full squat, what is the distance covered at the knee? Berapa untuk buat satu squat penuh? Berapakah distance covered? How much?
45 sir.
45?
90 kot.
90. Okay. Bila kita nak buat full squat, ni daripada dia duduk kepada dia bangun, is it full squat? One repetition of full squat, is it? Or no? Full squat ke tak? Ataupun lepas dia bangun, dia kena kembali ke posisi asal balik. Which is full squat? From 1 to 2 or from 1 to 3? Daripada kondisi 1 jadi kondisi 2 kita panggil full squat ke, ataupun bila dia kembali semula seperti kondisi 1? Which one is full squat? Macam mana pergerakan full squat? Daripada squat, bangun, and dia akan squat balik. That is one repetition. Okay. So to measure the distance, we need to measure the difference from 90 to 170. That is 80 degree of difference. And from 170 become 90 again. That is another 80 degree of difference. So the total distance covered by the region of knee during full squat condition is 160 degree. Ni dia punya pi. Okay, dapat tangkap? Do you get the idea how to measuring the distance for angular?
Dapat sir.
Dapat sir.
Okay. Soalan kedua. If this fella performing 10 full squat, how much distance covered by the knee? Berapa distance covered kalau dia buat 10 full squat?
1,600 sir.
1,600. Betul. Ini cara untuk kita kira distance. Okay. Alright. Another one, when we deal with problem, for angular problem, the unit satu kita report dalam degree. Okay. You can put it like that, ataupun you can put it like this. Mana-mana pun boleh. Yang kedua, always remember this. Transform this unit to radian. Always report to answer. So how we want to do a transformation? We know that 1 radian equals to 57.3 degree. So to change degree to radian, okay, macam mana kita nak ubah? We need to divide our answer with 57.3. Kalau kita nak tukar radian to degree pula, we need to multiply our answer with 57.3. Okay, example, kita dah ada 1600 degree, berapa radian? So it will be 1600 divide with 57.3. Itu jawapan yang kamu mesti ada. Okay, 1600 divide 57.3, 27.9 radian. So always answer angular case in both degree and radian. Okay, so degree ni dalam bentuk angular lah, dalam bentuk angle. Radian ni, we can actually substitute this radian into linear case. We need radian in linear case later on. That is the reason why angular case kita akan tukar degree kepada radian. Okay, now why 1 radian 57.3? To have an exact answer, please search on your own. Okay, to have an exact answer, please search on your own dekat YouTube. Ada je jawapan dia. Okay, I am going to give you one simple reason. Okay, this one, from the axis of rotation, okay, to the curvature, this is known as radius. Betul? Okay, radius. If we have two radius from point A to point B, the curvature here, this is also known as radius. Okay, it is also known as radius. Okay, at an angle of 57.3, radius A, radius B, and radius C, okay, A equals to B for sure, A equals to C for sure. Okay, kalau jarak dia. Kalau ini 10 cm, ini memang 10 cm. Mana boleh jadi lain kan? But at 1 radian, at 57.3, A equals to C at the same time it is equals to B. Maksudnya, kalau ini 10 cm, ini 10 cm, ini pun akan dapat 10 cm linearly. And that at that point, the radius or the angle is 57.3. And this is the reason, the simplest reason why 1 radian is known as 57.3 degree. Okay, to know the exact explanation of that, please find on your own. Pasal ni pengetahuan dulu-dulu ni, so I'm not going to touch on that. Okay, cuma saya nak kamu faham, any answer in angular need to be reported in both radian and degree. And how to do that? You need to do some simple conversion. Kalau dapat jawapan dalam degree, like this, divide that with 57.3. If you have your answer in radian, like this, nak tukar dia, so you akan kalikan dengan 57.3. You're going to end up in term of degree. So this is the conversion. Ni perkara kedua. Okay. Sorry, perkara kedua. Betul lah tu perkara kedua. Perkara pertama, the distance, which is known as pi. Perkara kedua, how to convert and how to describe the answer. Okay, dua benda. Okay, next one is where to read the angle. Okay, so in human body part, lah kita ambil example mudah. Take, okay, when we have intersection between two bones, joint yang kita nak cari tu, contoh, we want to seek angle at the knee. We want to seek angle at the ankle. We want to seek angle at the elbow. We want to seek angle at the palm, at the wrist. All of this part, we have an intersection bone. Such as untuk apa ni? Ankle ni, kita ada tarsal, kita ada kita punya feet dengan kita punya lower leg. We have the intersection. For the knee, we have your lower leg and upper leg region intersect here. For elbow, we have your upper arm and lower arm. And for the wrist, we have lower arm and the palm. So for those part that we have intersection bone, we are going to use relative angle to explain about the angular motion. Okay, apa itu relative angle? Relative angle is any angle that being made by intersecting bone like this. Okay, so angle-angle ini kita panggil dia sebagai relative angle. Means you need to have two bones intersect. And you need to have, you need to focus on the joints. The joint where two bones intersect. Jadi kalau kata kita nak tengok how much flexion occurs at the elbow, we are going to seek this angle. Berapa banyak flexion. Berapa banyak extension, we are going to seek this angle. This is known as relative angle. Apa yang kita nak tengok? Berapa pi dia. Okay. Tapi cuba fikir. If we want to see berapa banyak kita bongkok, how much we can bend down, means we need to see the rate of change, the change of angle at the lower back. Where at the lower back, we don't have any intersect bones. So we don't have any joint here. Intersecting joint. Bila case ini, seperti ini, we need to draw one imaginary line intersect with the bone in interest. This one is an imaginary line. And this line can be like this, vertical, or it can be horizontal. And we can only rely on imaginary line when there is no intersecting bone. Jadi imaginary line ni akan jadi kamu punya reference line. This is known as reference line. Okay, so from the reference line to the bone that we have interest, ni, this will be your pi. If you resolve to this kind of method, this is known as absolute angle, where we need to have a reference line. Apa benda yang kita nak baca dekat situ? Same thing. We want to know the angle ataupun dia punya pi. Okay. Sampai sini dulu. Do you have anything to ask? Ni dah pergi belahan macam siput sedut ni. Do you have anything to ask? Just up until now. Ada ke? Tak ada ke? Enggak ada ke?
Tak ada, sir.
Boleh faham Simple ni. Boleh Boleh faham? Okay.
Boleh, sir.
Alright, thank you. Now, okay, kita dah ada distance. We go back. Okay, kita dah ada distance, kita dah ada type of angle, relative and absolute, and you know what are the thing that you need to focus on. Okay, now let's go to the properties. Linear and angular. We have touched the first one. Distance, meter, and in angular it is pi nama dia. In degree or in radian. Okay. Second one, this one is scalar. Okay, second one, partner dia is displacement. Okay, still in meter, but for angular, start bergerak tiba-tiba pen ni. In angular, for displacement, dia sama juga bulat, tapi dia bukan tegak, dia nyerong macam ni. Sikit je beza dia. Nama dia ialah theta. I think you had me call this name a lot. Okay, theta. Theta dia berapa? Angle lah tu. Jadi degree, unit is similar, degree and radian. Okay, same as linear, displacement, theta is the same thing. Cuma, okay, contoh kita ambil jam tadi kan. Alright. Let's see. The watch move like this. Berapa dia punya pi? 90 kan? Berapa dia punya theta? How much theta for this one? Berapa? Come on, try. 90. The same. Sama macam distance kan? Ini case sini sampai sini. So, it is the same. If the clock hand continue. Now, the pi is 90. The pi is 90. The pi is 180. Theta dia berapa? Berapa theta dia? Berapa? Come on, try. Case yang sama.
180.
180. Yes, true. Okay, if it continue. Now, the pi is 270. How much is the theta? Berapa theta dia? Now is the trick. Mana lagi dekat? Daripada point ni pergi sini ataupun putaran ni? Which one is shorter?
90 degree.
So dia punya theta 90 degree but the direction is different. Tu je beza dia. Okay, itu aja beza dia. Okay, tapi case macam ni sangat-sangat jarang berlaku lah. Alright, selalu dia dah bagi dah theta berapa, pi berapa, just calculate that one, that's all. Okay, so in angular, theta ni is the displacement. Okay, the displacement. Sometimes they give you theta. If they don't give you, you need to find out. So the easiest way to find theta is actually by do this thing. Minus the first pi. The change of pi is the theta. Paling mudah. Okay. Now, the first one, I'm not going to talk a lot. We take a look at the second one. Velocity. Pasal theta dengan distance sama sebenarnya. Okay, straight dia. Cuma distance in a straight line, theta in term of angle. That's all. Okay. Velocity in linear is V equals to displacement over time. In angular, velocity is known as this symbol. W gemuk ni. Okay, ataupun nama kampung dia, omega. Omega. Okay. And it is actually as similar as velocity. So, kalau velocity, displacement over time, omega, displacement dekat dalam angular apa? Ni kan? Theta. This is the displacement. Jadi, dia adalah theta over time. Tu displacement. Okay, that is displacement pula. That is velocity. Okay. This is the velocity. Jadi kawan velocity ni kita ada apa? Kita ada speed kan? Speed ataupun S equals to distance over time. Beza ni je. Speed, distance, velocity, displacement. So same goes as angular. So kita ada satu lagi simbol macam ni. This is speed. Wait. Nama datang ni sigma. Okay. Sama macam kawan dia. Kalau untuk linear, it is distance. Untuk sigma, distance in angular is pi. Jadi dia adalah pi over time. This is angular speed. This is angular velocity. So I want you to open up your eyes. Take a good look. It is actually the same thing. The difference is just towards the symbol being used and where to find the data. Itu je beza dia. The formula is actually similar. Cuma ini V, ini omega. Ini S, ini sigma. Kalau bahagian atas pula, ini displacement, this is theta. If this one is distance, this is pi. Time tak pernah ubah, time sama. So it is actually the same things all over again. Okay, it is actually the same thing. So we can actually see here, okay, dekat sini, kalau velocity kawan dia omega. Okay, kalau velocity kawan dia omega. Kalau speed kawan dia sigma. Can you see this one? Can you see these possibilities? Nampak tak?
Boleh sir?
Okay.
Yes,
Alright.
sir.
So when we talk about interrelation between these two medium, linear and angular, we need to always add on one. When we talk about interrelation, always include radius. Dekat mana nak include? Dekat bahagian angular. So velocity is equals to radius omega. And speed is equals to radius sigma. Okay. So apa interrelation ni? Nanti kita tengok contoh. Saya tunjuk dulu apa interrelation. Example kan? Okay, we take simple example. A person try to kick a ball. Okay. When this person deliver an impact to the ball, okay, impulse, what is going to happen to the balls? Apa jadi dekat bola ni lepas orang ni sepak dia? Cuba infer. What is going to happen? Jadi apa? Apa terjadi kalau kamu sepak bola? It cause the ball to travel. And a travel ball will have velocity. Betul? Setuju dengan bahagian ni?
Setuju.
Setuju. Okay. What can you make in order to increase the velocity of the ball? What can you do in order to make this ball travel faster? Kita akan hayun kaki lebih laju. So, hayunan kaki, the act of kicking this ball is actually an angular motion. Means that we are going to have omega here. The speed of the tight rotation. If the omega is higher, the speed the tight is going to be faster. Betul? Setuju?
Betul sir?
Betul kan? Jadi inilah antara perkadaran dia. The speed of tide equals to the velocity of the ball. Okay, cuba kita kena masukkan kat sini satu R. Kita terbalik. Kita terbalik je nanti kan student pening. Tadi V kat depan dan V kat belakang. Okay, V equals to R omega, which show a relationship between the speed of the ball with the speed of the tide. Radius ni apa? Ni, between the axis to the contact point. So this are the radius of rotation. Ini R dia. Ni yang interrelation dia. So if we increase the omega of the type, the velocity of the ball is going to increase. These are interrelationship. So we have deal with the first properties. Okay, velocity. V equals to displacement over time. And omega equals to theta over time. Velocity apa? Ni velocity bola. Okay. Omega apa? Omega of the time. So, kita nak tengok theta dekat mana ni? Change dekat angle dia ni berapa terjadi. Selalunya dia akan bagi kamu theta dia berapa. So, these are the interrelation for velocity. V equals to R omega. The first properties. Nanti kita tengok contoh dia. Okay, velocity. Are you okay with this?
Okay, sir.
Okay. Mana saya punya nota? Kan kata tak bunyi pula. Situ. Dia kita sampai situ. Okay. Okay, ni relative angle. Absolute angle. Okay, and this one is measurement unit lah tadi. Degree, radian. How to change that. Okay, tu. Radius semua tu. Okay, nanti kamu baca lah nota ni. Okay, angular distance we have cover. Okay. And then we have angular displacement. Okay. And then we have angular velocity. Angular velocity omega lah. Omega equals to theta over time. Right. Next one is angular acceleration. Okay. Next properties. Sekejap Okay. Next properties is acceleration. In linear, we describe acceleration as velocity final minus velocity initial divide with time final minus time initial. Same as velocity. The case is similar. For angular, benda dia sama. Cuma angular, we name it as alpha. A juga tapi ada echo. Okay, this is known as alpha. So, alpha equals to omega final minus omega initial over time final minus time initial. Nampak tak? Benda yang sama. Benda yang sama. Kalau kata dalam linear, the unit is meter per second square ataupun meter per second square. In angular, the unit is degree per second square ataupun degree per second square ataupun radian per second square ataupun radian per second square. Ini dalam bentuk darab, ini dalam bentuk bahagi. Ini dalam bentuk darab, ini dalam bentuk bahagi. Kenapa ada negatif? Pasal dalam bentuk darab, dia kat bawah. Okay, kalau macam degree, ni degree per second square, ni sebenarnya bentuk dia macam ni lah. Degree per second square. Jadi bila kita naik ke atas, it will become negative. Okay, selalunya saya suruh ingat yang ini, senang. Slash S2. Nanti kalau kamu buat darab-darab macam ni, kamu letak S2 dia jadi terbalik. So it need to be S negative 2. But this is the unit that you may actually use. Okay. So acceleration, kita tengok unit dia dulu Jadi saya tunjuk contoh dia. Alright. So the interrelation for the acceleration. Okay, interrelation for the acceleration, we have two. Okay. So in angular acceleration, you need to know that kalau kita disuruh cari benda macam ni senang. Kadang-kadang dia bagi contoh macam ni saya bagi satu contoh. Let's say kaki ni, okay, point A. This kaki it move at 5 radian per second. Ni omega ni. Okay, however, after a certain period of time at point B, the same leak, okay, the same leak velocity had become 3 radian per second. Okay. Masa pertama, and this change occurs in 5 seconds. Okay. At the starting of the running, the speed of the tide, the velocity of the tide is 5 radian per second. However, after 5 seconds, the speed of the tide changed to 3 radian per second. So what is the acceleration value? Ini contoh penggunaan straight acceleration. So you just find what is the omega 2, 3 radian per second minus dengan omega 1, 5 radian per second divide with the time it occurs. So you are going to have -2 minus 5 minus pula divide with 5. Berapa kita dapat ni? So tak hilang. -2 divide with 5. We have -0.4 radian per second. Maksudnya dia deaccelerate. Based on the pictures pun kita dah tahu lah, if it start with higher numbers and end up with something that is lower, then it is an deceleration cases. Tapi ini in term of angular acceleration. Okay, 4 radian, 0.4 radian per second ni berapa degree? Can somebody please find out this one? Berapa degree dia? Can convert this answer to degree per second? Berapa dapat? .9 degree. Kalau kita nak masukkan per second, we are not going to put it as bulat tu, but kita kena letak macam ni, degree per second square. Okay, negative. This is the angular acceleration. Okay, now when we try to have interrelation between linear and angular acceleration, you need to know this thing first. In angular case, there are two linear acceleration occurs simultaneously. In order for you to get this angular acceleration, there are two linear acceleration occur simultaneously. One is angular acceleration at the surface. Contoh macam ni kan, surface ni, setiap bahagian surface ni, there are acceleration outwards. Okay, there are acceleration outwards. This acceleration determine surface kita jadi macam ni ke, ataupun dia jadi melonjong ke atas ke. Meaning that dekat bahagian lonjong ni, acceleration outwards dia lebih besar berbanding dengan acceleration inwards. Kalau acceleration inwards dia besar, dia akan ke dalam. So dia kurang melonjong. Okay. Kalau acceleration inwards and outwards dia sama, you are going to get a perfect circle. Value dia sama. So this acceleration or acceleration at the curvature, okay, this acceleration or acceleration at the curvature is known as tangential acceleration. Ataupun we are going to put it as A T, representing tangential acceleration. Tangential acceleration is actually linear acceleration. Okay, it is actually a linear acceleration. You can put it as V2 minus V1 over change of time. Ini acceleration. Ataupun, okay, ataupun if we want to have a direct relation with alpha, tangential acceleration is also equals with R alpha. Ataupun R omega 2 minus omega 1 change of time. This is the similarities. Okay, ini adalah persamaan. If you take a look back for velocity, kita ada straight persamaan. Mana velocity? Mana nota velocity saya? Ni, kita ada terus persamaan. But for acceleration semata tak ada. Okay, tapi we can have it from tangent acceleration. Barulah kita ada linear acceleration equals to angular acceleration in term of radius alpha. Radius dia mana? Radius dia ni. Jarak antara axis ke curvature. This is the radius. Okay. Second type of acceleration occurs at any angular motion is known as radial acceleration. Sekejap Okay, ni adalah acceleration type yang pertama. Second type of acceleration, kalau kita ada satu tangent acceleration at the curvature, we are going to have another acceleration from the starting point of the tangent to the axis. Kita akan ada satu acceleration ke dalam. Okay, tangent acceleration, acceleration keluar. So we are going to have one radial inwards acceleration daripada starting of tangent ke dalam. Daripada starting of tangent ke dalam, we are going to have another type of acceleration known as radial acceleration. Or we can put it as AR, radial acceleration. So radial acceleration equals to V square over R over radius. V ni V yang mana? Value of acceleration. Okay, linearly. Alright. When we have this kind of equation, ni interrelation for acceleration, both tangent and radial, interrelation of velocity V equals RW. This is the case where for the angular part, we need to use radian. Tak boleh pakai degree. Sama kat sini. For the angular part, we need to use radian. Tak boleh guna degree because radian is actually the projection of angle in term of linear. Jadi bila kita nak buat persamaan, kita tak boleh samakan itik dengan ayam. But we can have a similarities between itik serati dengan itik hitam. Something like that lah. So if the type is similar, the shape is different, is okay. But if the type is not similar, kita tak boleh buat persamaan. We need to convert it into a similar unit. So angular similarity unit with linear is radian, and that is the reason why for every single question in angular case, I need you to report both radian and degree. Kamu akan selamat di situ. So these are all the interrelationship and all kinematic aspect that we may have in angular case. Okay, ni dia punya mukadimah dia. Kejap lagi kita tengok contoh. Okay, ni angular acceleration. So we have alpha. Okay, like linear may be positive, may be negative. And then we have relation, interrelation. Apa tu interrelation yang paling mudah lah. So this one it talks about distance. S, distance. Okay, these are linear distance, the straight one. Okay, these are the linear distance. These are radius. Okay, these are the radius. Ini adalah radius of rotation. These are linear radius. So radius of rotation, linear radius. So when we try to find the relationship, lagi panjang radius of rotation, lagi panjanglah radius of curvature. So, kita akan masukkan R. Okay, linear distance equals to radius of rotation angle. Okay, bila masuk velocity, linear velocity sama dengan angular velocity radius. So the thing that bind all of linear towards angular is radius. Okay, is radius. And second thing, remember, the angular part need to be reported in radian, not degree. If we talk about relationship. If not, report both. Sama juga dengan yang ketiga, which is acceleration. Okay, which is acceleration. So we in angular acceleration, it involves two linear acceleration, tangent and radial. Kalau tangent banyak, so this curvature dia akan pergi keluar. Means kamu akan dapat lonjong. Dekat bahagian yang paling lonjong tu lah tangent acceleration paling besar, radial paling kecil. Dekat bahagian yang paling rapat dengan axis, radial acceleration paling besar. So tangent acceleration kecil. But if these two acceleration is equal in term of numbers, you are going to get a good curve rotation. Okay, ini persamaan dia. So tangential is actually a linear acceleration, while radial, ni bentuk dia lagi satu, is acceleration inwards. Okay, inwards. So we can actually, the second one ni, A equals to V square over R, ataupun you can have it as V square over T. Ni, as this one. Okay, antara dua. Selalunya kita akan pakai yang over R lah, pasal kita nak masukkan radius tu. Alright, yang ni abaikan. Ni kamu tengok betul-betul, actually it is quite similar with what we have discussed. Kalau kata dalam bentuk, do you still remember this? Ni kita ada 3 equation constant acceleration. Okay, 3 equation projectile, but this one they change into the form of angular. Okay, initial velocity become omega. Okay, acceleration become alpha, final velocity become omega. So dia tukar benda yang sama saja. So don't get confused. Okay, dia tukar benda ni. V2 equals to V1 plus ET. Ni V ni jadi omega 2 equals to omega 1 plus alpha T. Lepas tu kita ada apa? D equals to V1T plus half AT square. So D is distance. Dia akan jadi pi equals to omega 1 T, okay, plus half alpha T square. Ada benda yang sama. Ini kita ada V2 square equals to V1 square plus 2AD. So it become omega 2 square equals to omega 1 square plus 2 alpha pi. Linear, angular, linear, angular, linear, angular. It is the same thing. Okay, V equals to displacement over time. Omega equals to theta over time. Linear, angular. Apa lagi kita ada? We have acceleration equals to V2 minus V1 over T2 minus T1. Alpha equals to V2 minus, omega 2 minus omega 1 over T2 minus T1. Benda yang sama. Okay, benda yang sama. And then kita ada AT equals to V2 minus V1 change of T, or it can be R alpha. So these are the interrelationship between angular and linear. Okay, so benda tu adalah benda yang sama. So next, afterwards I'm going to show you some example regarding angular cases. So we are going to take 5 and we are going to meet again at 11:10. Can we make it 11:10 or 15-minute breaks? Boleh?
Sure sir, boleh.
Right. So after the break, I'm going to show you some example of cases for angular. Start from displacement up until acceleration, tangent and radial. So we take 5 and we meet again at 11:10. Thank you. Assalamualaikum. Selamat kembali. Mari kita pergi ke soalan yang pertama. Okay, kita ada beberapa contoh. So let's go from the most easy to the not so hard. The first one, let's say the same as the case of ni. Okay, tadi dekat squat kan. Okay, let's say we have ni. This is the first position. Change to second position. Okay lah, katalah macam ni lah. Okay, so posisi 1, posisi 2. Okay, let's see the relative angle change from point 1 to point 2 is 85. Okay, 85 degree. Okay, alright. If this fella perform 10 full squat, okay, so what is number 1 total pi, and number 2 total theta? Cuba cari. If from point 1 to point 2 is 85 degree of change. Okay, 85 degree of change. This is half squat. What is the total distance covered to perform 10 full squat? And what is the total displacement for 10 full squat? And remember, this is not full squat. Maksudnya dia akan patah balik ke posisi 1. So you have another 85 degree. So one full squat is 85 plus 85. 170 degree. So 10 to full squat, berapa pi kita ada? Total pi equals to berapa? Berapakah total pi untuk 10 full squat? If one full squat is 170 degree. So what is 10 full squat total distance covered? Berapa? How much? How much? Ada orang tak ada orang ni? Hello? Ada. Okay.
Ada,
So,
sir.
berapa? 10 full squat.
1700 degree.
Berapa radian? Change to radian. Divide with 57.3.
29.6.
6 ada belakang-belakang lagi kan?
66.
6, okay. 29.7 radian per second. Ataupun degree per second. Ni jawapan dia. So, how about the displacement theta ni? How much theta for 10 full squat? Theta dia berapa? So, kenapa kosong? Why the theta is 0? Because it is full squat. Means it starts and ends at the same point. That is the reason why. Okay, so let's go to the second one. Okay, ni issue jump. Okay, we have a watch. Mana yang saya punya pen? Okay, we have one watch and one long hand of the clock. So jarum minit lah. If this long hand move from 12 to 6, okay, it moved from 12 to 6. So find out the first one. What is the pi? Second one, what is the theta? The third one, okay, and the third one, what is the alpha? Silakan. Berapa pi dia? From 12 to 6. How about dia punya pi?
$180 ke sir?
Betul? How about dia punya theta?
180
Ada satu tertinggal. Apa dia?
radian.
Ni. Kenapa negatif? Sebab dia bergerak ke
Bawah.
bawah. Kan ni kan vektor displacement. Okay, how about the acceleration? Acceleration. Acceleration ni please think very very careful. Okay. Carefully think about it. So dia punya unit need to be degree per second. So that one is jarum minit. Ada berapa second dia nak bergerak daripada 12 nak pergi 6. 1 minit 60 saat. So kalau 30 minit berapa saat?
$1,800.
800. Betul? 30 kali 60. Ya ke? Macam pelik. Is it? 30 kali dengan
1800.
1800 tu. Alright. Okay. 1800 second. Saya ada tertinggal satu benda lah kat sini. Sebelum nak jumpa acceleration, kita kena ada velocity dulu kan. Sorry, tertinggal. Omega dia berapa? And then only we find out alpha dia berapa. So omega dia berapa? It will be displacement over time. It will be negative 180 over second. Dah buat berapa tu? .1. Okay. The velocity is 0.1 degree per second. Negative 0.1 degree per second. Okay, and finally acceleration dia. Acceleration dia ni kamu kena fikir betul-betul. Think carefully. Acceleration equals to omega 2 minus omega 1 over change of time. Omega 2 dia dekat mana? Sinilah. Omega 1 dia dekat mana? Starting lah. So, berapa omega 2 dia? Kamu kena fikir betul-betul kat sini. Think very carefully. What is the acceleration value of the long hand watch? Long hand of the watch, of the clock. Betul lah tu. What is the acceleration? Kalau kamu fikir betul-betul, you actually don't need to calculate anything at all. Ada acceleration tak dekat jarum jam? Is there any acceleration at the clock hand? Any clock hand? Is there any acceleration? Ada tak ada?
Tak ada.
Tak ada. Kenapa tak ada? Kalau dia ada, apa jadi dekat jarum jam ni? Sekejap dia perlahan, sekejap dia laju. So the time is not going to be accurate since katalah at portion A, jarum ni perlahan. At portion B, jarum ni laju. So the first 15 minute is slower than the second 15 minute. That is going to happen if the hand of the clock have acceleration. So the acceleration of this is actually 0. No acceleration. Okay, so think carefully about the case. Alright, Now let's go to number 3. We have a spin, gasing Kita ada satu biji gasing It keep on spinning. Okay, this gasing has a constant angular velocity. Angular velocity of 3 pi radian per second. Okay, dia punya kelajuan dia is 3 pi radian per second, and this gasing had spin for 20 seconds. 20 seconds. The question is, in 20 seconds, at this velocity, how many rotation or revolution had been made by the gasing? Silakan. Berapa? Okay, saya bagi tips, saya bagi clue sikit. Satu rotation of one full rotation is 360 degree. It is also known as one revolution. It is also known 360 degree ni juga kita tahu dia ialah 2 pi radian. Tiga-tiga benda ni sama. Okay, now in 20 second for a spin that's spinning at 3 pi radian per second, berapa banyak dia dapat pusing? Ni based on information yang ada dekat sini. So we know that 1 second dia akan pusing sebanyak 3 pi radian. So if 20 second, it is 3 times 20 equals to 60 pi radian. So if 1 revolution equals to 2 pi radian, 60 pi radian berapa revolution? Tu dah cara nak jawab dia. So 60 pi radian divide with 1 pi radian. Why 2 pi radian? Because 2 pi radian is 1 rotation. So kalau 60 pi radian, kita akan end up dengan 30 revolution ataupun 30 rotation. 30 kali gasing ni berpusing dalam masa 20 saat. Ni soalan senang. Saya jawab sendiri. Okay, soalan seterusnya. Counter clockwise means ke belakang lah kan? Counter clockwise. Oh, ke depan. Okay. Kita ada kaki. We take. Pen. Mana kamu? Sekejap Kan saya tak nak kerja sama. Okay. We have a leg. A kicker extended leg. Okay. Kaki ni dah tegak lah maksudnya. Tak cukup tegak. Sorry. Okay, dia dah tegak ke depan. Okay. We have a kicker means dia dah pergi ke depan. A kicker extended leg had been swung for 0.4 second. Okay. In counterclockwise direction while accelerating. So this leg have an alpha of 200 degree per second square. Okay. At instant of contact with the ball. Alright, so the question is, what is the angular velocity? Okay, dia suruh kamu cari what is the angular velocity of the leg at the instant of contact with the ball. Maksudnya dia nak kamu cari angular velocity dekat sini. Ni, dekat bahagian sini, contact. Ni angular velocity final ke angular velocity initial ni? Is it initial ataupun final? Come on guys. Maksudnya dia bagi tahu kaki ni dalam masa 0.4 saat it accelerate at 200 degree per second. So the question is, what is the angular velocity at contact? Meaning before it swung, it will start somewhere. And at this point, dia pun akan ada velocity. This is velocity initial. So this one is velocity final. Okay, so from initial to final, it takes 0.4 seconds. So you can do the math by alpha equals to omega final minus omega initial over the time. Dapatlah jawapan dia berapa ada dekat sini. Because omega initial dia sama dengan kosong. Dia start static. So can you find it? We have 200 equals to omega 2 minus 0 over 0.4. Okay, apa jawapan dia? Macam mana kita nak buat ni? We need to substitute things first. It will become 200 times 0.4 equals to omega 2 minus 0. Dah tak ada lah. Dapatlah jawapan kat situ. Omega 2 equals to how much? Okay, how much guys? Simple je tu.
80.
80 apa?
Degree per second square.
Degree per second ni omega. Omega degree per second saja. Alpha baru degree per second square. Alpha ialah acceleration. Omega ialah velocity per second saja. Okay. How about radian? Macam mana kita nak tukar jadi radian? Bahagi dengan 57.3. Degree to radian
1.4.
divide berapa?
1.4.
1.4, right. That's true. Ni kena jawab macam ni. Okay, so let's move on to the third one. Alright, now we have the case of running. Okay, running. Dua kondisi. Point 1, point 2. Okay, let's say the angular velocity of a runner type. Tadi masa point 1, it is 3 radian per second. Ni omega 1 dia. Okay, and omega 2 dia ialah 2.7 radian per second. And this change occurs in 0.5 second. Okay, so what is the angular velocity at the time? Berapa angular velocity dia? Balikkan je case tadi. Lepas tu berapa? Velocity 2, 2.7. Velocity 1, 3. 0.5. So how much you have it? Soalan senang je ni.
1.8.
Apa? 1.8? Kamu pasti 1.8? Tengok pun nampak macam tak 1.8 je, 2.7 tolak 3. 2.7 tolak 3 bukan 0.3. Memang bedal ni. Betul ke salah tu? 1.8.
Salah sir.
Ah,
Negatif 0.6.
negatif 0.6. Dah bagikan Okay, negatif 0.6 apa? Ni tadi dalam radian. So dia adalah radian per second square. Now change this into degree. Kalikan dengan 57.3, berapa kita dapat?
Negatif 34.38.
34.38. Dapatlah. Degree per second square. Ni dia. This is how you solve the equation. Okay. Now let's try another one. Okay. Yang ini kita tengok interrelation Jap. Okay. Golfer. We have a golfer. Okay, golfer. Di nak cue ball. Swung, planar, motion, right-handed golfer, arm length. Initial velocity of the ball. What was the angular velocity of the left shoulder? Point of contact. Okay. So maksudnya dia dah contact. This is tangan, this is kayu, this is bola. And the bola, the tangan had already swung. Okay. And the bola had already fly. We have impulse here. Okay. Let's say the golf club. The golf club, the length of this club. Sekejap, saya tulis kat belakang. Tu depan tu bola. Okay. The length of this club is 1.2 meter. Okay, dia punya length. And then the golfer arm ni daripada axis of rotation ni sampailah ke pergelangan ni is 0.76 meter. Jangan ni. Tangan panjang se kayu golf pendek asal lain lah. Ni lukisan perumpamaan. Okay. So panjang tangan 0.76. Panjang kayu golf 1.2 meter. Okay. At the point of contact, it caused the ball to have initial velocity of 35 meter per second. Okay, of 35 meter per second. The question is, what is the angular velocity of the shoulder at the point of contact? Maksudnya berapa laju shoulder ni swing in order to get this velocity. So dia nak kaitan antara velocity dengan omega. The ball velocity and the shoulder velocity. So we need to add on radius dekat sini. And this radius is rotation radius. So rotation dia mana? Bukan tangan saja yang rotate, but the whole complex is rotation. Means from the axis to the end of the club. So the radius here is actually hand plus club. So can you find out the omega? Ni mesti jawapan dalam radian per second. Pasal kita punya soalan perumpamaan antara persamaan antara linear dengan angular. So we know that V equals to 35, equals to R 0.76 sampul 1.2. So you are going to end up 1.96 meter omega. Jadi omega ialah 3.5 divide with 1.96. Berapa kita dapat kat situ? Berapakah jawapannya? How many omega do we have?
One point eight.
1.8 apa? Ya ke kamu 1.8? Are you sure 1.8? 35 bagi 2 tu. Korang-korang mesti belas-belas. 35 divide 1.96. Katalah kita ambil 2 kan. 35 bagi 2 pun dah ada 17 point berapa? 17.5.
9 sir.
Berapa 17 point?
9.
9 radian per second. Okay. Tu jawapan dia. Sekarang kalau nak tukar jadi degree dah boleh, tak ada masalah. Okay, kalau you end up macam ni pun tak ada masalah. Because when we talk about interrelation, it need to be in radian. Meaning here, the shoulder rotate at a velocity of 70.9 radian per second in order to have the ball travel at 35 meter per second. Tu maksudnya. Okay, now let's move on to the next one. There's quite a similar case. Okay, now is about a flying sling. Flying sling ni macam tukul lah, macam tukul Thor macam tukul Thor. Okay, let's see. Adalah mamat seorang ni. Okay, it swing a sling. So this sling is being swing and release. Okay, if David 0.75 meter sling, maksudnya sekarang kita dah ada, we have the distance here. Okay, kita dah ada R equals to 0.75 meter. If this swing, if this sling being accelerated, okay, so we have alpha equals to 20 radian per second square, and this acceleration occurs after 1.5 second. Okay, the question is at the point of release here. Okay, bila dia lepas release ni, benda swing ni, what is the velocity of the stone? Faham? Berapa laju batu yang dilepaskan ini? At the point of release, what is the velocity? So it is still similar. We have velocity equals to omega R omega. Omega R pun sama sebenarnya, tapi nanti kamu confuse. R omega. Tapi maklumat yang kita ada ialah alpha. Okay, so the first one you need to know omega dia dulu. Barulah kamu boleh tahu berapa velocity. So you need to know at the instant of release, what is the angular velocity of the system. Maksudnya kamu kena cari dia punya omega 2 dia. Because omega 1 dia dalam kes ni kosong. Can you find out? Omega 1 kita tak tahu. Okay. So alpha 20 radian equals to omega 2. We don't know that. Minus 0. Sama dengan 0 pula. Minus 0 over the time. So x equals to 20 times 1.5. 6 radian per second. Iya ke? Aku salah bagi. Macam kepelikan ni. Betul lah. Betul lah kan? Over time, pergi sebelah. Okay, 6 radian per second. Now, we can find out V dia. V equals to R 0.75 times with 6. Dapatlah berapa laju bola itu terbang. .5 meter per second. Okay, dapat tu. Semua dapat?
Dapat sir.
Okay. Alright. Sekarang kita pergi kepada soalan yang lebih susah. Okay, this next question require you to use multiple phase of equation. Okay. Angular velocity, the heat, angle. Okay, so soalan ni macam ni. Kita ada satu player softball. Kayu hit bola. So maksudnya dia dah hayun kayu lah. It hit the ball and the ball travel. Okay. A softball is struck by a 46 cm away from the axis of rotation. Maksud dia sekarang, dari ujung kayu baseball sampai sini, kita assume the axis of rotation equals to 0.46 meter. Okay, this is the axis of rotation. The radius of rotation is 0.46 meter. Okay, and this rotation have an angular velocity. Okay, the motion itself have an angular velocity of 70 radian per second. If the ball is hit at a height of 1.2 meter. Panjang ni. Sekejap saya tengok kat mana 1.2 meter dia duduk dulu. Okay. If the ball is hit at 1.2 meter. So maksud dia macam ni. Bola ni akan travel ke depan. Okay. This ball is going to travel like this. It being hit 1.2 meter at an angle of 45 degree. Will the ball clear a 1.2 meter fence 110 meter away? Okay. Oh, faham? Boleh faham ke tak? Soalan dia dulu. Can you understand the question? This ball, okay, this ball being struck. Maksudnya sekarang dia dah kena pukul. Okay, it being struck at an angle of 45 degree. Maksudnya masa dia pukul ni kan, masa dia naik ni, okay, the angle is 45 degree. Okay, and the height of the ball during contact, means during contact point ni tadi, the height is 1.2 meter. Okay, the radius of rotation complex of the hand and the bat is 0.46 meter. The velocity of the swing is 70 radian per second. So ada dua bahagian sini. Okay, satu, we need to know velocity of the ball travel. Dua, how is this ball going over the fence that's stated 110 meter away from the batter. Dapat tak dia lepas pagar yang sama tinggi dengan jarak pukulan dia ni tadi 110 meter. So 110 meter ni D. Alright, we have two parts here. These parts okay, this part need to be solved by V equals to R omega. And the second part need to be solved by equation of constant acceleration. Maksudnya apa? Dekat sini kita sebenarnya tengah cari projectile. And this projectile, okay, saya dah lukis projectile ni. 1.2 ni tadi sebenarnya hanyalah untuk mengaburi mata pihak kamu. Means that the question is when it start and ends at the same level. The angle of projection is 45. The horizontal component is 110 meter. So we try to determine, is this ball can reach 110 meter. If it can reach 110 meter, dia memang akan lepas pagar 1.2 pasal dia mula pada tinggi yang sama. Tapi kalau jawapan dia less than 110, maksudnya dia akan jatuh bawah 1.2 meter. So you now try to prove whether this ball is going to travel 110 meter away. So these two part of equation. Let's solve the first one. What is the velocity of the ball? We need to know the velocity of the ball first, and then only kita boleh guna dekat sini. Barulah kita boleh gunakan ni equation nombor berapa ni kalau kita nak tahu berapa jauh dia pergi. What equation we are going to use? Equation number 1, equation number 2, or equation number 3? V2 equals to V1 plus AT to find time. This is equation 1. D equals to V1T plus half AT square. This is equation number 2. And equation number 3. V2 square equals to V1 square plus 2AD. And this D is much more for vertical. Second equation D is much more for horizontal. So we are going to consult the second equation. And you know by going through second equation, horizontal case, A will equals to 0. Jadi kita dah boleh buang yang belakang. We just going to do D equals to V1T. And we try to prove whether D dia ni is 110 or not. If the D is 110, it will move beyond the fence. But if D is less than 110, dia akan langgar pagar. Ni maksud dia, okay? Because dia bagi 1.2 tu untuk bagi tahu kamu it is actually the same height. So if it can travel more than 110, it will move over the fence. If it travel less than 110, dia kena pagar. Okay. So why we need the V? Simple. Because in second equation, kita missing satu benda, nampak? Kita missing T. We need to find T lah dulu. T by equation number 1. So let's move one by one. So we start with finding the initial velocity of the ball after being struck. Okay, so we have V equals to R omega. V kita tak tahu. R berapa? 0.46 meter. And omega dia ialah 70 radian per second. So how much is V? It will be 0.46 times 7t. 32.2 meter. Ni kelajuan bola. Kita belum masukkan kelajuan bola dengan angle lagi. Okay, so now first one, we need to find out time. Okay, in order to find out time, kita akan consult equation number 1. V2 equals to V1 plus AT, where in this case, V1 equals to V sin theta, V2 equals to 0. Dia apa? A equals to, berapa A? Negative 9.81. Okay, A equals to negative 9.81. And T, we try to find out. Berapa kita dapat kat situ? Berapa T dia kita dapat? Okay, 0 equals to V kita berapa? 32.2 sin 45. Okay, so we have V sin theta. That is V1. Lepas tu plus negative 9.81 T. So we are going to send this part to the left hand side. We have 9.81 T equals to 32.2 sin 45 22.77. Jadi T equals to 22.77 divided by 9.81. We have 2.32. 2.32 second. And this is actually T up. So kalau total T total equals to T up plus T down. And since it said that the start point is equal with the end point, T up and T down is similar. Ini projectile yang kita belajar minggu ketiga dulu. Means that T total sama dengan 2.32 times 2. Berapa dapat sini? 4.64 second. Okay, we have found the time. Now, to the third equation. Okay, to the third equation. To the second equation. D equals to V1T plus half AT square. And since the case is horizontal case, A equals to 0. Boleh potong tu semua. Jadi kita ada D equals to V1T. Now, V1 is V cos theta. Why V cos theta? Because this is horizontal case. Vertical case, sin. Horizontal case, cos. Ini kita dah bincangkan dulu. Okay, T. T here is T total. Jadi berapa kita ada? 32.2 cos 45. Okay, lepas tu time with 4.64. Berapa dapat? 45 cos 0.71 kali dengan 32.2 kali dengan 4.64. We have 105.6. meter. This is what will be covered by the ball. 105.6. Meaning kat sini, dia jatuh dekat 105. 110 lah dia jatuh dekat sini. So the ball is actually travel dia lepas tak pagar tu. The answer is the ball is not going to go over the fence. Why? Because the ball just travel 105 meter, but the fence being situated 110 meter away from the batter. So the answer is the ball is not going to go over the fence. It will fall before the fence. Tu soalan. Kita kena tengok step by step. Okay, that is how you solve problem. Alright. So you have any question regarding what we have learned today?
No, sir.
No. Alright. If you don't have any more question, this will serve as the end of today's class. And as for the tutorial class Thursday, I'm going to give you some question for you to solve, and please submit those question before the end of tutorial hours. Saya akan buka daripada hari ni. Okay, daripada pukul 2 nanti sampailah hari Khamis. Kamu punya will be 3 hingga 5. So please submit the answer before 5 on Thursday. You may discuss on how to answer that. Tak ada masalah. Boleh bincang. Okay? Boleh?
Okay, saya boleh.
Alright, so that will be the end of our class. Thank you for your participation. Don't forget to take your attendance. Assalamualaikum and thank you to everyone.